Yeah, today I would like to speak about reverse image search, but done specifically for e-commerce systems. The topic of reverse image search has been already mentioned, but I think that we can also cover some basics. But I would like to present a clear strategy of how to implement that if you have an e-commerce business. I guess that might be also applied in some other domains, but that really depends on what you're trying to solve. But before we start, let's see how any particular e-commerce website may look like. Let's consider what is the status quo of any particular website that is selling some items. So basically, every e-commerce application, no matter if it's built using Magento or WooCommerce, Shopper, whatever tool you can imagine, will follow this simplified pattern. So there will be a transactional database, something like SQL or NoSQL database, think of Postgres. And there will be also a full text search engine, probably Elasticsearch, OpenSearch, or Maily search-based tool, but it doesn't matter that much. This architecture will be solving the problem of providing some search capabilities into your customers. They can go into your website, provide a textual query, and this textual query will be then used to find some relevant items. And no matter if you have a huge search department, they will be, in a nutshell, working on making that efficient, so your customers will receive the most relevant items possible. And probably if you work in a huge e-commerce business, there might be even a huge team of people working solely on search. There is also a sync process required to keep things in sync. So whenever you are running out of some specific items, those shouldn't be rather included in the search results as well. So there has to be a sync process that will be taking care of that. Some people may also be trying to solve that using a single database. Let's say you may choose MySQL database and try to use its full text capabilities to perform the search. But in reality, that won't be performing that well because you have low control on the search results in such a setup. But as a result, you can provide rather simple functionality. Your users may type in a textual query and receive some products that might be relevant for that query. That requires some process of converting the input query into some root form, so we can easily compare the words being used in a query, in the document, in the product name, for example, or its description. But sometimes that might be not enough. In some specific industries, it might be also beneficial to expose a different way of performing the queries over the documents or over the products we have. And that may require providing a way to perform the search using some different modalities, for example, images. That's what reverse image search is used for. It's a different mechanism that allows using photos, usually taken with your mobile camera, and using those to query your database, so you can receive the results not only based on the textual search, but also using some similarities in the way how your inventory look like. Basically, there are different scenarios in which you should consider implementing reverse image search, because that's not designed to support any kind of business. For example, if you sell some products which are not really, which cannot be really, well, let's say the visual aspects of your inventory are not that important, you don't really need to have a reverse image search. If you work in fashion industry, or if you sell, I don't know, plants, that might be pretty important to expose a way of searching not only with textual description, because it might be quite hard to describe what you exactly need just by using text. Then you may consider introducing reverse image search, because that might be a valuable feature. But let's say if you are selling some computer inventory, let's say batteries to laptop batteries, then probably it's quite hard to distinguish one from the other just by having a look at the image. There are some product IDs which are way more important in order to distinguish the items. So in that scenario, you don't really need to have a reverse image search in place. This is also pretty important to have this kind of mechanism if your customers are coming from different backgrounds. Let's say if all your inventory is described using English, but some of your users would prefer to use a different language to search over the inventory. This is also pretty useful because they might be using a different language, and if English is not their mother tongue, that might be just an easier way from a user experience to describe what they need. And this is also pretty important to introduce if majority of your traffic comes from mobile devices. If your users are rather using pretty old computer or laptops, it may be just a bit harder to provide a good quality photo. But if you have a mobile in hand, that's pretty easy to take a picture and search for something similar. And fashion e-commerce is especially one of the industries that may benefit from introducing this kind of mechanism, because that's quite a typical problem. Let's say if you are looking for a specific piece of cloth, you can take a picture of something similar, or just look for something similar in the internet and provide it as your query. And that would be way harder if you were supposed to describe that particular piece of cloth using only text. And it cannot be done using the old means. I mean, the full text search is not capable of solving that, but semantic search is, of course, a way of solving the problem of reverse image search. Semantic search is based on vector representations of our input data, and those vector representations, aka embeddings, are being created using some deep neural networks. So your deep neural network takes any kind of data, that might be an image, but also a text, video, whatever we train it for, and then creates fixed dimensional embeddings out of any input data we provide. And semantic search do not work on pixel level. And that's what we are actually looking for, because image search cannot be solved on pixel level. It's not resistant to any kind of image manipulation like zoom or crop or anything you can imagine. If we did that on pixel level, that won't be solving anything at all. But semantic search and vector embeddings are capable of capturing not only the pixel relationships, but also the semantics. So what exactly is being presented on the picture. One thing to know, because I'm quite often surprised, people ask that question quite often, if that captures some text which might be also present on the images, and it's not like OCR. Definitely, if you want to look for a specific text that is being presented on an image, you are looking for a different thing, because semantic search and vector embeddings will capture the whole meaning of the picture only, not the subtle details like the characters present on the image. And that might be used for different modalities. So basically, we have a specific model, specific deep learning network, deep neural network, which converts input into n-dimensional vectors. So this dimensionality is fixed. So a single model creates vectors with a specific number of output dimensions. And this is fine because that enables some useful properties. Input images may be of different resolutions, but if we have fixed dimensional vectors, it's way easier to compare them to each other. And the general idea is that if two different images represent a similar concept, a similar product, then their vector representation should be quite close to each other in that vector space. This is pretty useful. That means we can calculate some sort of distance or similarity measure and use it as some kind of proxy to determine the relevancy of the documents given the image query. Okay, so there are two different processes involved in reverse image transfer. The first one is an offline phase that you need to perform at least once at the very beginning, because you need to index all the images of the products you sell. So you need to convert all the images into their vector representations and put them, store them in a way that will be efficient to perform the search. And that the tool that you can use for that, there are plenty of tools available, and depends on the load that you expect and the number of products you are comparing to. You might be preferring some different ones. And that process should be repeated every single time we have some change in the input data. Let's say we have a new item to be sold. And if we detect this change, we should already create the embeddings of all the images of that particular item and expose them to the search mechanism, so we can sell the new products as well, not only the old inventory we have. So there is a sync process required, but the same was true for the good old full text search. And there is also an online phase. So whenever we receive a query, we need to vectorize it using the same model and use this new vector to perform the similarity search, typically using nearest neighbor search in some way. Then the nearest neighbors are being used as the relevant documents, and they are just being served to back to the user. So initially, in any e-commerce business, we would have this kind of infrastructure. But now, if we want to perform the reverse image search, we also need two additional tools. The first one is our embedding model. So this is a neural network capable of encoding our data into the vector representations, but there also needs to be another system, a vector search engine, that will be performing this nearest neighbor search efficiently. If you sell, I don't know, a few hundreds of items, then you may not be requiring this sort of a vector search engine, and you might be fine enough to write a custom library that will be performing this nearest neighbors using a full scan approach. But if you want to have it implemented in a scalable way, then you definitely need to choose a proper vector database, aka vector search engine, that will be performing that efficiently. In that setup, we also need to make sure that we extend our sync process, because right now it cannot update the full text search engine only, but it also needs to make sure that our vector search engine is up to date with all the changes that could happen in the meantime. But those additional blocks, structuring your application in that way has a huge advantage, because you are not changing the previous state. So you are free to use the full text search capabilities in exactly the same way like you were doing before. But now you have some specific systems responsible for a new feature. So nothing really changes comparing to the previous setup. Those vector search engines and full text search engines have different scaling patterns. So that's probably not the best idea to combine those together, because it makes the previous full text search engine enriched with the vector search capabilities may simply become a bottleneck of the whole process. And reverse image search is not the most important feature you will be serving unless you work in a very specific domain. So maybe it's a better idea to keep things separated. But okay, I mentioned embedding model, but there are plenty of possibilities of how to choose a proper model. So let's just quickly review what is available. And the hard way would be definitely to start training your models from the very beginning. So that process requires having some data scientists on board that can, first of all, design your network and then train it. But the full training process, full training cycle takes a lot of time and a lot of computational power, and that means money. But there is a different way of how to solve that, because there is plenty of pre-trained models available, which might be pretty good, as a starting point. And there is also a way to fine-tune them further for your specific needs. So that's probably the proper way of how to start with if you want to implement fairly quickly. So there are a lot of pre-trained models available, and there are mostly Python-based libraries exposing them. So if you are familiar with Python toolkit for data science, then you are probably also familiar with at least one of those tools. Torch Vision is a part of PyTorch exposing the computer vision models. And there are plenty of pre-trained models such as ResNet or EfficientNet that may be just taken out of the shelf and use to encode the data into the embedding space. There is also a pretty interesting project called Embeddr. If you prefer pandas-like API, that's also a good choice. This is a wrapper around the other libraries that exposes the embedding models using this pandas-like or scikit-learn-like API. So this is pretty interesting if you just want to experiment quickly, because that gives you an ability to start experimenting pretty fast if you are familiar with those standard libraries. And surprisingly enough, sentence transformers, which is one of the most popular NLP libraries, at least when it comes to embeddings done on text, also exposes some models which can encode images to the vector latent space, to vector embeddings. So this is also pretty interesting. And sentence transformers in particular exposes clip model, which is pretty popular. There are also some tools that you can use as APIs if you don't want to bother about setting up your own model. That might be also pretty challenging. I'm also going to talk briefly about that in a second. There are also some SaaS solutions like Aleph Alpha that exposes some models as a REST API, so you can freely use them also to encode your inventory in such a setup, and then you don't really need to worry about this embeddings model at all. Clip, that has been already mentioned recently in one of the previous talks at least, is an OpenAI model that is capable of encoding text and images into the same vector space. And that has pretty useful properties. First of all, you can enable the reverse image search because you don't really need to use this text modality at all. That also gives you an advantage of enabling the semantic search over the text queries using the same model. And that's pretty interesting. And using Clip is pretty easy if you decide to use sentence transformers. This is taken directly from their website, and those few lines of codes actually runs the instantiates the clip and encodes both image and some text into the same latent space, into the same embedding space. This is really cool. There is also a different variant that supports 50 languages, over 50 languages out of the box. So if your customers are using different languages, this is also pretty cool. This open AI clip model may be also fine-tuned easily, and Sentence Transformers website describes a way of how to perform this fine-tuning quite easily. So this is pretty good as a starting point. But there's also a challenge that I mentioned, how to serve models if we want to do that on your own. And there's plenty of available tools, but I guess if you are familiar with any kind of, if you are already using some sort of models in your company, then you are probably pretty familiar with different ways of how to serve the inference of those models. So this is pretty obvious for you, but if not, I just mentioned a few projects that might be useful if you have no experience with that. Some also try to build a fast API application over the model of their choice. So this is also pretty interesting. There are some general usage tools mentioned here, but there's also Clip as Service, which is Gina AI project that specifically works with Clip model and exposes it in a simple way, so you can integrate that without worrying much about the infrastructure or about setting up the infrastructure needed for model inference phase. But if you have no experience in serving machine learning models in production in your organization, then you can probably choose some SaaS solutions, and that would be way easier for you. But okay, I decided to use Clip, and I just need to elaborate a bit about why it is a good choice for reverse image search. And there are various advantages of Clip, but the multimodality already built in is like the biggest one in my opinion, because if we decide to use Clip or a different multimodal model, we have this advantage of running not only the textual queries using full text search mechanism, but we can also easily integrate the semantic search to the textual queries in the future, and that would be way easier than using a model that do not expose a way of converting text into the same embedding space. We could of course serve a different model, but in reality, that's way easier to just use a single one, and that enables searching for using textual queries to search for matching images, or using textual queries to match different text. So that's way better if you want to use some different approaches here. But up till now, if we decide to use this stack that I suggested, that already enables two different ways of performing the search queries. First of all, we have textual queries, so the pretty old mechanism that we already had before, and there's also a reverse image search available right now, so we can use this embedding model and perform semantic search over our images, over the images of our inventory. But we can also easily integrate the semantic search on text and build so-called hybrid search. Hybrid search is not yet solved. I need to say that. There are different strategies that might be used of how to incorporate full text search and vector semantic search, but none of them actually solves that. In some specific scenarios, you may prefer to perform only full text search. Let's say if your inventory has some specific IDs and your customers are using those IDs to find the relevant items, then you probably want to have a full text search mechanism, because vectors won't be able to capture some unique identifiers of your stock. But if your users tend to provide some longer queries, so-called long tail queries, then the full text search may struggle with finding some relevant items because it has no idea which words are more important. So in such scenario, you would prefer to run the semantic search over your queries. So this is one of the strategies: use full text search for shorter queries and increase the importance of semantic search for the longer queries. There are plenty of ways of how to implement hybrid search. There are also some challenges. The one that I mentioned, when to prefer full text search, how do we re-rank the candidates created by both systems? That's still a challenge. There is a lot of things related to learning to rank. So using some different machine learning models to perform the re-ranking on the results of both search mechanisms. This is still an open topic, and we have a pretty interesting article about hybrid search on our website. The QR code will point you directly to the article, but there is also a link. And we describe different ways of how to integrate BM25, which is one of the most popular algorithms used for full text search, how to combine it with vector search, and we compare different options. So if you are interested in seeing some numbers, this is, I guess it's pretty interesting article. But okay, we have described how to integrate that, how to expose this reverse image search into your e-commerce system. But there is also a challenge of how to serve this vector search production. I mentioned that already, but if you have just a few items, then you are probably pretty fine with performing this full scan and compare to all the items for every single query. That will be scalable enough. But in reality, if you serve thousands of items and your inventory changes quite frequently, then you need to think about having a proper vector search engine. And Qdrant, vector database or vector search engine I work for, is one of the choices. It also uses HNSW. That algorithm has been mentioned already today, but this is the most popular algorithm for vector databases nowadays because this is really performant and scalable and can be parallelized easily because those HNSW is based on graph-like structures, and those might be divided into multiple segments. So that enables easy scaling. And Qdrant is written in Rust. That gives us a performance boost already. We have an HTTP and gRPC protocols in place, but also some official SDKs making things even simple. You can run it locally because this is an open source solution. You can run it locally even without spinning up a container because we have a local mode built into Python SDK. So that's fine for some quick experiments. But if you want to scale things up, you are able to run it using Docker containers or Kubernetes clusters. We support them out of the box. You can also compile the binaries if you prefer that. But we also have a cloud offering with free trial available. So if you want to try it out, that's also one of the ways of how to do that easily without setting up a new component in your whole architecture or infrastructure. But there is also a different feature already built in, which is filtering mechanism. We have an extensive filtering mechanism built in that allows to perform the vector search along with some additional criteria on top of that. And this is already integrated with the vector search phase, what makes it really efficient. We are also focusing on making the vector search affordable. We have introduced mechanisms like product and scalar quantization recently that enabled us to run billion scale vector search on a single machine, higher end. Definitely, but if you want to run it on a Raspberry Pi with millions of vectors, that should be also possible. Okay, and those additional filters are really important in e-commerce, especially in the fashion industry, because the similarity is not all that you want. Your customers may prefer a different fabric, a different color, while keeping some traits similar to the query image. Or they may want to buy a piece of cloth manufactured by a specific company. So you need to have those additional criteria built in, and Qdrant solves that perfectly. But okay, let me just wrap it up. I just presented the strategy of how to incorporate that to any system, no matter what e-commerce platform you use and no matter what full text search or transactional DB you prefer. But if you want to enable your users to perform not only textual queries, but also to be able to provide an image as a query and still want to be able to provide some relevant results, that is strategy that you can already incorporate. And using Clip has a huge advantage because you can not only query based on the input images, but you can also query using some more sophisticated descriptions, and that should be still able to capture the semantics of the textual queries. And using a single neural model, you can do that pretty easily. There are still lots of challenges of vector search because choosing the right model is not that easy. Clip is one of the options, and fine-tuning Clip is still possible. So maybe that's a good starting point. But if you work in a very specific domain, there might be a different model that works better in your specific industry. If you have no experience with hosting the model, that might be also challenging, but I mentioned a few tools that might be useful for that. Fine-tuning, if the model doesn't work well in a specific area. But there is also something that hasn't been solved yet. I mean, how to update your embeddings efficiently. Because let's say you fine-tune your model and you have millions of items in your stock. Then you need to recompute the embeddings for all the images of your products, and that may take a while. So computing those embeddings is a bottleneck of whole system. And quality measure. I think that we forgot about quality in the world of embeddings. We need to be able to compare the quality, and in terms of e-commerce, that might be proxied by using some KPIs that you are already tracking. So if your conversion rate decreases after introducing the reverse image search, or if it's lower for the reverse image search than it was for textual search, then you might be struggling a bit with that. So that's a good proxy to do that. And if you prefer looking at the source code, we have prepared this e-commerce notebook. The QR code will point you directly, but this is also available in our examples repo. There is a whole notebook that takes Amazon product data set, converts those images into embeddings, and then performs the reverse image search. We try to keep it platform agnostic. You might be using some different tools for your e-commerce, and no matter if you use WooCommerce or Shopper or whatever you prefer, this might be also pretty easily integrated into an existing stack without changing much in the previous workflow of your website. That should be like a small feature, but not the major important thing that would be used by majority of your users. And if you have any questions, I'm happy to answer them right now. And you can also feel free to drop me a message using my social channels.
Fantastic. So speaking of questions, you have 2 in the Q&A.
Yeah, let me just open that. Okay, so the first one is, can we use vector embedded to track objects moving from one frame to another? If there are objects in one frame and their position has moved in the next frame, can we compare the embeddings of these objects and find the exact location of these objects in the new frame? I'm not sure if any vector embeddings can capture that really. That's more about object detection. And I would say if we just keep in our eye, if we are performing the object detection, then that's the proper way of how to solve that. But vector embeddings are typically trying to convert a whole image into the vector space. So they are not capturing the position of different objects, but rather a whole meaning of that particular picture. So I would say that's not the best way, but I may just not know some of the research that has been done recently on that. And another question is about how do you rank between textual and vector search? In other words, can we boost one search over the other? Yeah, actually, that's one of the challenges I mentioned, because it's not obvious of how to integrate both textual and vector search. One of the strategies that has been suggested quite often is to use some sort of linear combination, because both full text search and vector search will produce some sort of a relevancy score, and those two might be used to perform some kind of linear combination, but that rarely works in reality. So I would say this is still challenging. I think that learning to rank is a proper way of how to do that. So you can integrate not only the relevancy scores of textual and vector search, but you can also integrate things like how many words in the textual search were out of the dictionary that you have, or things like how long was the query, and many other features. So now I think that having a separate model, probably something simple like tree-based model, that will be making the decision of how to rescore, how to re-rank those candidates is pretty important. But a common strategy is also to perform full text search at the first place. And if full text search doesn't provide any results, because that may happen, then you can use a vector search as a fallback, because vector search will be always producing some results. They might be not that relevant as we would expect them to be, but two different items are always similar in some way. And the similarity may be low or high, but still we can produce some results. So that also increases the user experience, let's say, just because if they provided a query that wouldn't be captured by the full text search, without the semantic search, we will be just able to say I don't know what you mean, or I do not have anything that matches your criteria. But with vector search as a fallback, we can always provide some results, and hopefully they will be meaningful enough so they can choose an item that works for them and buy it. Okay, do you think there will be some benefits of using some kind of RHF or KPIF to decide how to update the embeddings model? Basically, I know that there is a pretty interesting project called NaniML that aims to measure the quality, and they are able to measure the quality of the predictions of your model because they are trying to estimate the error. This is pretty complex idea, but NaniML is the name of that tool. I really encourage you to have a closer look. They also have one strategy of calculating the expected error and the actual error of your model, also for multivariate, so for the embeddings. So this is pretty interesting strategy of how to measure that, but there is no easy answer to that. Like it's really hard to say if your embeddings are good enough, but that's also an issue with the whole search industry. There are lots of bias in search just because we cannot provide ground truth to all the possible queries. Hope that answers the question.